For the next part of the lecture, we will consider piecewise functions and their limits. So for example, let us consider this function here, f of x, which is given by x squared minus x minus 2 divided by x plus 1 if x is less than 0, and f of x is equal to the square root of 4 minus x if x is greater than or equal to 0 but less than or equal to 4. And f of x is equal to the polynomial x squared minus 5x plus 4 if x is greater than 4. Now we want to know the limit of the function f as x tends to 4. Now note that 4 is a junction point of the piecewise function. So we need to consider the one-sided limits. So let us first look at the limit of the function f as x tends to 4 from the left side. This means that we want to consider x values that are very close to 4 but less than 4. So for example, you can take as a test value the point 3.999999. Alright? Now, since here x is less than 4 but very close to 4, the definition of the function f is given by the square root of 4 minus x. So this one-sided limit here is the same as the limit of the square root of 4 minus x as x tends to 4 from the negative side, from the left side. So again, we may take 3.99999 as our test point. And when we plug in that point to 4 minus x, which is the radicand of this radical, we will get something that is very close to 0 but is positive. So we have the square root of 0 plus. Right? So in other words, the limit of f of x as x tends to 4 from the left side is equal to 0. Now, let us look at the other one-sided limit. What is the limit of f of x as x tends to 4 from the positive side? So here, x is greater than 4. So we have to use the quadratic x squared minus 5x plus 4 as the definition of our function f. So let us take the limit of this quadratic as x tends to 4 from the right side. So actually here, all we need to do is to plug in 4 to this quadratic and we will get 4 squared minus 5 times 4 plus 4. And that will give us 0. So we see that in this particular example, the two one-sided limits agree and they are equal to 0. So the conclusion is the limit of the function f as x tends to 4 is also equal to 0. Now, let us consider the same piecewise function f, and this time we want to consider the limit of the function as x tends to negative 1. Now, note that here, negative 1 is not a junction point of the piecewise function. So which definition of the function f are we going to use? Is it the first expression, the second, or the third? Now note that when x is tending to the number negative 1, that means that we are considering x values that are less than 0. So when taking the limit of f, we need to consider the expression x squared minus x minus 2 divided by x plus 1. Now let us take the limit of x squared minus x minus 2 all over x plus 1 as x tends to negative 1. We see that when you plug in negative 1 here in the numerator and in the denominator, you get the form 0 over 0. Alright, so what we need to do is to factor the numerator as x minus 2 times x plus 1. And we see that x plus 1 is a common factor of the numerator and the denominator. So we can factor out x plus 1 and cancel this x plus 1 in the numerator from the x plus 1 in the denominator. And so we will be left with x minus 2. Now the limit of x minus 2 as x tends to negative 1 is negative 3. So in this case, the limit of f of x as x tends to negative 1 is equal to negative 3. Now let us consider a different example. Here, we want to consider the quotient of t plus 4 divided by the absolute value of t plus 4. And here we want for t to approach negative 4. Right? Now let us recall that your absolute value of t plus 4 can be expressed as a piecewise function. And precisely, the absolute value of t plus 4 is t plus 4 when t plus 4 is positive. So in other words, when the number t plus 4 inside the absolute value sign is positive, you can simply drop off the absolute value sign. However, if the number inside is negative, you need to multiply the expression inside the absolute value sign by -1. And so, the absolute value of t plus 4 is equal to negative of t plus 4 if t plus 4 is negative. Now, the first condition that t plus 4 is greater than or equal to 0 is equivalent to t being greater than or equal to negative 4. And the condition that t plus 4 is negative is equivalent to the condition that t is less than negative 4. So we see that since we want to consider the limit as t tends to negative 4, and negative 4 is a junction point of this piecewise function, we need to consider one-sided limits. So let us first compute for the limit of the expression as t tends to negative 4 from the left side. That means that t is less than negative 4. Since t is less than negative 4, the expression absolute value of t plus 4 in the denominator will become negative of t plus 4. And we just write the numerator as is, and so we will have t plus 4 divided by the negative of t plus 4. And so performing the division, we see that we will get negative 1, and negative 1 being a constant, the limit of it is equal to negative 1. Now let us look at the other one-sided limit. So we want to consider the limit of t plus 4 divided by the absolute value of t plus 4 as t tends to negative 4 from the right side. That means that t is greater than negative 4. And in this case, the expression inside the absolute value sign is positive. So we can simply drop the absolute value sign. And so we will get t plus 4 divided by t plus 4. So for this expression, we get the quotient equal to 1. And so taking the limit of 1, we get 1. So we see that the left-hand limit is equal to negative 1, while the right-hand limit is equal to 1. So since these two one-sided limits do not agree, we conclude that the limit of t plus 4 divided by the absolute value of t plus 4 as t tends to negative 4 does not exist.